Good morning, Algebra 3 students. Hopefully you're on here and listening in. I really wish I could see your faces. It's really strange just standing here in my living room talking to you, but that's just where we are right now. So I hope that you're able to reach out to each other and that you're just kind of enjoying the experience of not having to anybody tell you what uniform to be in, or that you need to put your phone away because, hey, guess what? Keep your phone out. Anyway, I miss you guys, and I hope that everything's been going well for you. I'm giving you this quiz review today so that you can be ready to take a quiz over the next couple days. The way that I intend to do this is in one way, shape, or form, I'm going to get you a copy of the quiz questions, and then how you are going to submit them is you are going to get a Google Doc quiz that you fill out the answers, and I'm going to break it into two parts. You're going to take part of it tomorrow and you're going to take part of it on Monday. I do ask that you submit them by 3 p.m. I don't want you to be holding on to these things and having your whole weekend taken up or staying up till midnight or anything like that. I know that you have to have a little bit of downtime as well, so just get that out of your road fairly early. The first 10 questions will be on Friday, and the second 8 questions, there's 18 total, will be given on Monday. The questions will be 6 points each for a total of 108, so there is some extra credit on there. And I'm also going to tell you how I want you to type in your answers. So this quiz review is a little bit more extensive than your reviews usually are, so yay. You hopefully will do an excellent job on your quiz. I'm going to go over all the topics and review how to do everything. And then it'll be up to you to make sure that you have your notes handy. Now, as far as the expectations, I need to rely on your honesty for these. You are going to be expected to take your quiz. I will say that I'm going to encourage you to use your notes that you've written down. However, I don't want you going and Googling things and rewatching videos while you're in the middle of the quiz. I know that sounds a little bit strange, but I do want you to still make sure that you know how to do things with minimal helps, because those of you, especially those of you that are going to use this at some point in the future, you need to make sure that you master the concept. So once again, I'm going to have to rely on your honesty to do that, and I'm also asking that for the quizzes and the tests that you don't phone a friend for these things. It's not meant to be a Skype thing, not meant to be a sharing answers and seeing what somebody else got. Definitely share with homeworks, but these remote quizzes and tests, I'm going to just ask you to please follow those guidelines, and that's just it. So let's just get right on with this quiz review. First thing that you're going to need to be able to do is to convert degrees to radians and leave your answer in terms of pi. So if you remember, degrees to radians involves multiplying by pi over 180. In this case, in order to leave your answer in terms of pi, you do have to reduce the fraction. Depending on your skill at reducing fractions, you might just cancel things out, but you can always reduce a fraction on a calculator. If you don't have this particular calculator, you can use your resources to figure out how your personal calculator works. If you have an Android phone, you can always go to Wabbitemu, Wabbitemu, search for that, and you'll be able to get a calculator. I'm going to make it into a fraction, just to remind you how to do that. Math frac, 7/4, so this would be 7/4 pi. Now, as far as how you're going to type your answer into the Google Doc, I know that not all, most people don't necessarily have a math editor, and I'm not looking for that. I don't want that. If you're going to type your answer in, if you typed it in, you would write 7 divided by 4, and then just write in the word pi, 7/4 pi. That'll be easy for me to mark. It'll be easy for you not to find special symbols, and you can write that in fairly nicely and easily that way. You're hearing my dog walk around here. He's wanting to move around, so there, I'll let him move around a little bit. The other thing is converting radians to degrees. Radians to degrees is just when you take that and you flip that fraction over, so you're doing 180 degrees over pi. In this case, the pi's will cancel out. Once again, you can use a calculator to reduce this thing by taking 5 times 180 divided by 9. The pi's will cancel out, or you can, if you're good at canceling out yourself, then you can look what goes in, but just in case you need to rely on the calculator, 5 times 180, and then divide your answer by 9. And then that gives you your 100 degrees. The pi's canceled out. Now, if there wasn't a pi and you were looking for an approximate answer here, you would then have to just make sure that you included pi in your calculation. You would type in 100 and write in the word degrees. You know that doesn't take very long. Many of you are like turbo fast on the typing of things, so hopefully that won't be a big deal for putting that into the Google Docs quiz, which there will be a link provided. I have not yet created that. I am working as quickly and as diligently as I can on these things. All right, and another one would be finding the exact value of certain things in terms of pi. These are the type of problems you're going to use the unit circle for. So what you should have is a copy of the unit circle next to you when you do this. So far, these are all of these things I've talked about so far are part of those first 10 questions, including this particular skill. So what you need to do is you need to remember your values for sine, cosine, tangent, cotangent, secant, and cosecant. So if you're looking for the cosine of 7 pi over 6, you move yourself around until you get to the 7 pi over 6, and you look at the coordinates, x coordinate, y coordinate, and since the cosine is the x coordinate, then your answer is negative square root of 3 over 2. So it's a matter of use your unit circle. If you wrote it, you should have been writing it down when we went over that in class last week. But if not, then just have a unit circle there in front of you so that you can refer to it. Make it a little bit bigger if you need to so that you can see every piece of it. If you're looking for the cotangent of negative 7 pi over 6, well, notice that the negatives aren't here. It's really going backwards. So some of you could probably handle going backwards, but if we want to get it in the range of values that you see here, really, if you want to find out what is around the circle one time from a negative value, what you need to do is you need to add pi to it. Oops, there we go. This is that part. We need to add 2 pi to it, I'm sorry, because 2 pi goes all the way around the circle. So if I have negative 7/6 pi plus 2 pi, that's negative 7/6 plus 12/6. You could also use a calculator on it. You could use, and you're just bringing the pi along for the ride. So negative 7/6 plus 2. And then we do math, frac, and enter. My dog's done roaming now. And we got 5/6, so that's 5/6 pi. So where you look on the unit circle is you go around to 5/6. You find your x and y value, because all of these have to do with the x and y value. Remember, it's the unit circle, so r is always 1. We don't have to deal with that. So I'm looking here, and negative 7 pi over 6, the same as 5 pi over 6. That takes me here. X is negative square root of 3 over 2. Y is 1/2. The cotangent is x over y. So when you do x over y, you're really taking x divided by y, which is the same as times the reciprocal of 2. The 2's cancel out, and you end up with a negative square root of 3 here. The way that you would enter these answers on the quiz when you get to that particular question, for square root, you can write, and since it's negative, make sure you put a minus or a dash in front of it. Negative square root 3 and then divided by 2. May not be the most elegant way to do it, but it's good. I'll know what you mean if you do that. And then over here, if you want to do that, you're going to type 5 pi divided by 6. 5 pi divided by 6. Oh, wait a minute. That would be if you're looking for this. So actually, this is not right. Okay. What we need to type in, sorry about that, but this actually will just give us an opportunity to see it being typed in, so it's not such a bad thing, because our actual answer is negative square root of 3. Ooh, this is being very touchy right now, so let's do that. You're going to type in negative, is it going to, oh, it's not even going to let me. Why? Let me let's see if I can get this to work. Okay, so we'll type in negative, there we go, now it's working. Square root 3. Just like that, because that's your final answer for the exact value. I don't want the calculator value for this. I want negative square root 3 to be your actual answer here. So that's how you would type this in. Unless you have a math editor, but really it's not necessary, so you don't need to do that. Let me get this out of the way. All right. So our answer right here is negative square root 3 here. The answer here is negative square root 3 over 2. And these are exact answers. They're not the decimal approximations. I do not want that. So you're not actually just taking your calculator, setting it to radians, and plunking this answer in. You have to think about it. You have to use your unit circle and go right there. That's part of what you learn in trigonometry. All right. Okay, now up to here is what the first 10 questions will be. So this will be the part that you'll be taking tomorrow, and then on Monday, I'll put up the link to do the next 8 questions. And this would be something like find the exact value of S within a given range. So you're looking for the angle, once again, in terms of pi. So your answer is going to be found in a certain range. So you're going to identify where that range is. So for example, here, you're going to look just for answers that are right here from here to here. And for this one, you're just looking for answers that are in this range. And then we can work through as far as how to figure out, well, wait, what is the actual answer here? All right, so I already told you this is where we're going to be looking for this answer. This is where we're going to be looking for this answer over here. Let's start with the tangent one. Remember that tangent is y over x. Okay, so we're looking for a y over an x value in this range where you get an answer of the square root of 3. Okay, You're looking for y over x, where you get an answer of the square root of 3. So you look at these values, and when you're looking at these values, you're looking for a y that's going to land you with a square root 3 in the numerator and for everything else to cancel out. Your eye should go to these two because both of them involve a square root of 3. But when you pick and plug in, the only one that's actually going to give you a square root 3 as an answer will be this one. Remember, this means divided by, and divided by means times the reciprocal. This should say times 2 over 1. Times negative 2 over 1. Okay, please forgive that. I'm going to bring this over here. The answer's right, it's just got a wrong detail in there. So negative square root 3 over 2, easiest way to fix it will be make it into a divided by. That is still not going to let me even do that. That's all right. That's all right. Negative square root 3 over 2 times negative 2 over 1, because you were starting with negative square root 3 over 2 divided by negative 1/2. So when you do that, the 2's cancel out. Negative times negative makes positive square root 3. So that's really where this answer comes from. I will change it for the nice neat notes that I'll put up later. So in the meantime, the work's on the other page. Dividing by negative 1/2 gives you actually the square root of 3 there. So the way that you would type in the answer for that, because our answer is really 4 pi over 3. Because you're looking for what S value has the ordered pair that's going to give you the square root of 3. So our answer would be the square root, the answer would be 4 pi divided by 3. 4 pi divided by 3, because that's the S value that gives you the correct answer. The ones that involve sine, cosine, secant, and cosecant are a little bit easier because they involve only one variable. So this one, you're looking for where 1 over x equals negative 2. So if you're looking for where 1 over x equals negative 2, what you're really looking for is where x equals negative 1/2 if you solve it for x. So the place in this zone from pi over 2 to pi where the x value is negative 1/2 is this ordered pair right here. None of the others have an x value of negative 1/2, and it's at the 2 pi over 3 place on your unit circle. So 2 pi over 3 is what S equals. In order to type in this answer, you would write 2 pi divided by 3, just like that, with a slash for your answer. So you can use the word pi in your answer. All right, moving right along. You need to be able to find the measurement of the central angle. Okay, when we say to the nearest degree, it just means you're going to round whatever answer you get to the ones place. And you have a formula for that, and your formula for that is S equals R theta. S, in this case, is the distance from here to here. Theta is your central angle in terms of pi. So this one's simply 14 is your measure of your arc. 17 is your radius. So 14/17 is your theta in radians, but the question's asking for the nearest degree, so you have to convert that into degrees using your degree formula. Here's where you'd have to be careful when you use your calculator. You're going to do 14 times 180. You might even want to do it in steps. Come on, there we go. 14 times 180 in your numerator. You got your answer. Divide that by, and I'm going to put 17 pi in parentheses, otherwise the order of operations will mess you up. And so you get about 47 there, and you would type in your answer, you would write in 47 degrees. And that's how you would express your answer to that question. And once again, we're now into the second part of the quiz that you would be taking on Monday. Finding the area of a sector. This is where you use your area formula. Area equals r squared theta. 1/2 r squared theta. Theta, though, has to be in radians first. So in order to make it into radians, 110 pi divided by 180. Notice that here I went ahead and put it into decimal form. Okay, because some questions are just better served that way. We plug in our formula. A equals 9.2 squared times 1.92. And that's in radians. As long as there's no degree mark, it has to be assumed that that's in radians. And once you've put that in the calculator, you can use 0.5, and any calculator you have should be able to handle this, because even if you don't have a square button, most do, even your phone calculator has a square button. But even if it doesn't, you can just do times 9.2 times 1.92. And that gives you about 81, or 81.3 if we're doing it to the 10th place. So here, 81.3 square centimeters because it's an area, so you want to make sure you've got a good thing going with the units here. Okay, couple of word problems that are not scary. Somebody had actually asked about this, so I'm killing two birds with one stone. I'm responding to your question as well as providing this in review form. If you know the radius of the Earth, and city A is about 18 degrees latitude, and B is at 29 degrees latitude, so you're picturing that circle where you've got the two different spots on the edge of the Earth. And in order, first of all, to find the number of degrees between them, you need to subtract. But our formulas don't work unless you make them into radians. So you would convert it into radians. Once it's into radians, S equals r theta. And you would figure out that through that, it's 1,229 kilometers apart for these two cities that are at those two latitude markings on the Earth. Okay, so a nice simple formula. Don't forget to subtract. Don't forget to change it into radians before you use that formula. And then also you could have a thing where you've got, we saw a problem like this where you've got like a wheel and this pulley is going to be rotating and pulling up a weight. So if you know that the radius is 12.3 inches and the question is saying how much will it rise if it's rotated up through 15 degrees, these are all just different ways of asking you to use this same formula for how far along the edge does it travel. So through 15 degrees, once again, you've got to convert it into radians first. You've got the answer in radians. S equals r, radius, times your theta, and you get about equal to 3.2. And when you're doing a linear measure, it's just 3.2 inches. Okay, the square is reserved for if you're looking for an area. So that's it. Once again, the first 10 questions will be presented to you on Friday, and then the last 8 questions will be presented to you on Monday. You'll fill out a Google Doc to submit your quiz. Please make sure that you get them submitted on time, and then I'll be able to evaluate them and release the grades to you. When you get the grades released to you, you will be able to see them. If you're on some phones or if you're on a laptop, you'll be able to click a view button to view your results. And otherwise, you'll be able to view the results, but you might have to look for them a little bit and click around in a white space on the bottom. There's something weird with Google Docs that does that, especially if you have an iPhone. So that's all I've got for you. I'm praying for you, and I miss you an awful lot, and hopefully we'll be able to see each other soon.